Hello everybody, welcome to today's lesson. We're going to talk about section 9.3. We will discuss rotations in geometry. This will be the last lesson of the year. I want to thank everybody for, well, not everybody, but I want to thank those who have watched my videos. They're not the best thing in the world, but hopefully they will help some of y'all. They are the notes that I would have given in class, so hopefully they help y'all kind of learn a little bit and understand how to do the problems I've been assigning from your book. So again, thank you for listening to my ratchety voice the last 7 or 8 weeks. Sorry you had to listen to it. At least you haven't gotten to see my ratchety face. So hey, here we go. 9.3 rotations. All right, so a rotation is a turn around a point. It's when you turn a figure around a point. There's got to be a point that you're rotating or turning it around. Sometimes they say about a point instead of around, just semantics or choice of wording. It means the same thing. Now, there's two things you need when you're going to rotate. You need to know what direction you're going, either clockwise or counterclockwise. And you need to know how far to turn it, which is the number of degrees, okay? So you need those two things to know how to rotate or turn it, okay? Rotations can be kind of tricky for some people because when you rotate and turn, you're not only turning the figure, but as you're turning the figure around the point, the figure itself is kind of turning, which means that, for example, a point that was at the top before you turned it or rotated it might be on the side or at the bottom in a different location at the end of the rotation. So the orientation of the shape usually changes as well, okay? All right, so some basics. We're going to keep things simple, and the degrees that you're going to turn are going to be quarter of a circle degrees. So 1/4 of a turn would be 90 degrees. If you're told to turn 180 degrees, that's halfway around the circle. 3/4 of the way around is 270, and a full circle or turn is 360. You will not be asked to rotate 360 degrees because that's just going back exactly where it started. So you really won't be asked to rotate that. Now, you'll be told which direction, either clockwise or counterclockwise. Now, in your book, if it does not specify a direction, you're going to assume counterclockwise, okay? So if it does not, again, in the book, if it doesn't tell you what direction to rotate, you're going to rotate it counterclockwise in the opposite direction that the hands of a clock would go. Now, I think that is because the quadrants on a grid, which is how we're going to rotate, always on a graph or grid so we know exactly where to go. I think it's because the quadrants go in order 1, 2, 3, 4 counterclockwise. Oops, I got that backwards. So counterclockwise would be that way. So I think by default they want counterclockwise because that is the order of the quadrants. But either way, remember that, okay? Now, here is the process or main rule we're going to follow, okay? Because again, sometimes it can be tricky knowing exactly where the point is going to end up, okay? Since we're on a graph or a coordinate plane, we're going to go by X and Y coordinates, by where the points are going to end up, okay? So we'll rotate each point individually and then draw or make the shape once we know where the points in the image are going to be, all right? So the main rule we're going to follow is right here. On the coordinate plane, every quarter turn or 90 degrees that you go, which means you go a quadrant. Every 90 degrees or quarter circle is a quadrant movement. So every 90 degrees or quarter of a circle or quadrant you move, what we're going to do is swap or switch the XY coordinates. Okay? So if we're told 90, we swap the XY coordinates. If we're told 180 degrees, we swap them twice. 90 for the first, 90 for the second. So 2 swaps or switches. If we're told turn 270 degrees, that's 3 of these worth. So we're going to swap or switch 3 times. All right? So again, every 90 degrees of the degrees as you're going, you're going to swap or switch XY coordinates. So you might swap them or switch them once, maybe twice, maybe 3 times. And then and that's going to tell you the XY coordinates at the end where they're going to end up. But the last thing you have to figure out are the positive, negative signs, okay? And that's based on the quadrant. Like, for example, if you know a point ends up in the 4th quadrant, that means it's a positive X, negative Y. Or let's say, for instance, if it ends up in quadrant 1, that's a positive X, positive Y. Quadrant 3 is negative X, negative Y. Quadrant 2 is negative X, positive Y. So once you know what quadrant it's going to end up in, you can figure out your positive, negative signs. And then you're going to swap or switch the coordinates every 90 degrees you turn. Okay, so here we go. Let's try some of these. Number 1, here's our triangle ABC, our pre-image. We're going to rotate it 90 degrees about the origin. Okay, so instead of around, sometimes we'll say about. So, right now you're in quadrant 1, the triangle. Okay, all the points. If you go 90 degrees and there's no direction, so remember the default, no direction indicated, is counterclockwise, which is this way. If you rotate these points all in quadrant 1, 1/4, that's 1 quadrant worth. So you know they're going to end up over here in quadrant 2. So all of these points, 90 degrees, moving 1 quadrant worth, are going to end up in quadrant 2. All right, and you know quadrant 2 is X negative, Y positive. All right, so we'll do each point individually. Here we go. This is real easy. Point A, you want to get the coordinates of A. A is at 6, 7. If you swap those once for 190 degrees worth, swap them once, that's 7, 6, right? And then you figure out negative, positive. Well, in this quadrant, X is negative, Y is positive. So make your X negative, keep your Y positive, and boom, there you go. That's where A prime is going to be, at negative 6, positive 7. So we graph that. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. There's A prime. Let's do B. Coordinates of B are positive 7, positive 3. We swap those once for a 90 degree turn. That means the coordinates are 3, 7, but again, X is negative, Y is positive, so the coordinates are really negative 3, 7. So that's B prime. So we plot that point, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. B prime. And the last point, C, the coordinates are 3, 5. So we swap them to 5 and 3. And the X is negative, so it's really negative 5, 3. We plot that point for C prime. Negative 5, positive 3, C prime. And once you have the image of your 3 pre-image points, you can make your triangle. And there you go. You have the image or the rotation of triangle ABC. All right? All right, let's try another one, number 2. We're going to rotate triangle DEF right here, 180 about the origin. All right, so you start in this quadrant, which is quadrant 2. You're going 180 around the origin. Now, if you're going 180, that's a half a turn. Doesn't really matter if you go clockwise or counterclockwise. But again, 180 is 290 degrees worth. So that's a quadrant and another quadrant. So if you're in this quadrant and you're going one quadrant for 90, another quadrant for 180, you're going to end up in quadrant 4. So you know your shape is going to end up in quadrant 4. All right, let's do our points separately. And think about this. If you're swapping once for the first 90 and then swapping the numbers back for the second 90, you might as well not even swap them, right? Because you're switching or swapping the numbers twice. So you don't really have to swap at all if you're going 180. Just figure out negative, positive. Like, for example, let's look at point D. Point D, the coordinates are negative 8, 2. Well, if you swap them once, 2, 8. Swap them again, 8, 2. But in this quadrant, the x is positive, but the y is negative. So it's going to be 8 and 2, but it's going to be positive 8, negative 2. So we're going to graph positive 8, negative 2 for D prime. So positive 8, negative 2. There you go, D prime. For, let's just do F. F right here is at negative 3, positive 2. Well, swap once, swap twice, so the 3 and the 2 stay. But the 3 is positive, 2 is negative. So it's 3, negative 2. So we graph that. 1, 2, 3, negative 2. So there is F prime. And E is at negative 3, positive 9. So it's going to be a 3 and a 9, swapping them twice back to where they started, but it's a 3, negative 9. So 3, negative 9. There is E prime, and voila. Your image, triangle DEF. Okay? Let's try one more full rotation on a grid. We did a 90 and 180, so let's go to number 3 and try a 270. A 270 is 3 switches, 3 quadrant movements, 90, 90, 90. So you switch back, you switch. So they're going to end up switched, okay? Now, if you look at this triangle, it's a little different than the first two because, look, you've got a point in this quadrant, a point in a different quadrant, and you've got a point in no quadrant at all. It's actually on the x-axis, but that's okay. Just do each point individually and connect them at the end, and you should have an accurate rotation, okay? All right, so here we go. Sorry about the pause there. I had to check to make sure I was focused in. All right, here we go. So, now we don't have letters. That's no big deal. Let's just do the points. Let's start with the point on the axis right here. This point is at negative 8, 0. Now, first we have to think about where it's going to end up. So 270 counterclockwise. So look, a 90, the first 90 would be here on this axis. The second 90 would be here on this axis for 180, and then the third 90 for 270 would be on this axis. So this point is going to be right here for 190, 2, 180, 3, 270. Okay? And remember, they're going to be switched at the end because you switch them back to original, switch them. So they're going to be switched or swapped at the end. So it's going to be a 0 and an 8. And if you're on this axis, the 8 is positive because you went up 8. So it's a 0, comma, positive 8. So graph up 8. And this point should end up there. All right, let's do this point right here. The coordinates here are -4, 2. So they're going to end up switched. And look, this quadrant, if you go 3 quadrants worth, 1, 2, 3. So it's going to be in this quadrant. In this quadrant, the x is positive and y is positive. Both are positive. So you're going to switch them for a 2 and a 4. And both are positive. So 2, 4 is where that point ends up. And the last point right here. The coordinates here are at -6, -6. So that's easy. It's going to be a 6 and a 6, obviously. But try to find out what quadrant it lies in. 1 quadrant for 90, 2 quadrants for 180, and 1 more for 270. So that point is going to end up in this quadrant. And in this quadrant, the x is negative, y is positive. So it's a 6 and a 6. X negative, y positive 6. So it's a really -6, 6. And we graph that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And there we go. 3 points, all accurate. We connect them. And there you go. All right. Let's look at number 4. It reads, triangle MOP, the vertices are here for M, here for O, here for P. Now, the question is, what are the coordinates of O prime? Remember, prime is where it ends up at the end. What are the coordinates of O prime after a 270 clockwise rotation about the origin? Now, we don't have to graph the whole thing. You can if you want, because all we're concerned about is O. Here's the starting point or coordinates of O. We got to know what are the coordinates at the end. So we really only have to worry about O. Now let's draw a little mini graph to see what's going on, because you got to know where it ends up for positive, negative signs. You know that a 270 is going to switch once, twice, 3 times. So these numbers are going to be switched at the end. So you know the 4 is in the front for X, 8 is in the rear for Y. Now, we got to figure out positive, negative. Well, O starts at 8, -4, which 8, -4 is in this quadrant somewhere, quadrant 4. If you go 270 clockwise, that's 3 quadrants worth clockwise. Clockwise is this way. So 1 for 90, 2 for 180, 3 for 270. So you know the point's going to end up in this quadrant, quadrant 1, where both numbers are positive. Positive X, positive Y. That means the 4 for the X and the 8 for the Y are both positive. So you keep these both positive, and there you go. That is where O prime is going to end up. 4, 8, both positive. Those are the coordinates. All right. All right, guys. Those are the examples 1 to 4. Real quick, at the bottom of the notes, I gave you a hint for homework problem number 32A. I told you on focus, you're only going to do part A on 32. And here's a hint. It gives you the graph of a triangle. You're supposed to find out the coordinates. Well, it tells you that it's 5 seconds worth out of a 30-second rotation. Well, 5 out of 30 is 1/6 of a circle or rotation. And 1/6 of a full circle 360 degrees is 60 degrees. So that means the triangle they give you guys, which is right here, you'll see when you look at the problem, that means that angle is 60. 90, which makes it a 30, 60, 90 triangle. And we've gone over those ratios before. Remember, short leg is your X, twice that is your hypotenuse, 2X, and across from your 60-degree angle, your longer leg is X squared root of 3. Well, they give you the hypotenuse, I think it's like 200. So knowing these ratios, you can solve for the short leg and the long leg. So that's why it tells you, that's why I tell you 3690 triangle, hypotenuse is 200, so you can find both legs, given that information like we've gone before, and that will help you get the coordinates, which is what you want for that problem. All right, so try that on 32A, and you should be okay on the rest. And that's it for today. Thanks, guys. I will see or talk to you some other time. And have a great rest of your year. Get all your work in. Do all problems. Show all work. You know the routine. You know the deal. Get the best grade you can. Have a great summer. Great rest of your year. And hopefully I'll see some of you guys in the hall next year. Take care. Bye-bye.